As any big thing, worldviews are properly appreciated at a distance after a certain period of time when they essentially crystallize. Even these days, we discover a thing or two about the Aristotelian worldview, Cartesian worldview, the Newtonian worldview, but it's safe to say that the thing that we're working with has been crystallized. It's in there. Unlike the contemporary worldview, which is in a state of a constant flux. It's constantly changing. And when we say contemporary worldview, we essentially mean the period of the history of science since the 1920s, since general relativity and quantum physics. And you can imagine so much has happened since the 1920s. So it's almost impossible to incorporate that into one worldview. So what I'm going to give you today is a clumsy snapshot of what we have at this moment, and just a tiny fragment of it. So what do we have here? We have quantum physics, general relativity, cosmology, chemistry, genetics, biology, neuroscience, psychology, sociology, economics, history, mathematics, hypothetical deductive method. I'm going to start with this one, neuroscience. When it was established in the early 1900s, it brought about a very important transition from dualism to the contemporary view on the subject. If you ask the scientific community, how would you explain ideas, thoughts, emotions, anything that has to do with the human mind? Let's say thoughts, emotions, feelings, they cannot exist without some material substratum. It can be a brain, it can be a processor, anything, but there must be something material that holds and produces the thoughts. The thoughts cannot exist independently of something material. So we believe that psychological phenomena are produced by the processes in the brain. Now individually, again, at the individual level, especially if you have a religious worldview, you may be inclined to believe that the mind can exist without material body, but we're talking about the views accepted by the community, implicit in our theories. And this is one of the things that is implicit in our theories. We believe that anything we think must be somehow connected to what happens at the level of the brain. Essentially, the processes in the brain are interactions between neurons. It's fair to say that we do not quite understand the exact nature of the correspondence between thoughts and interactions between neurons. We do not quite understand how to produce a certain line of reasoning by manipulating certain neurons. We're not there yet. But one thing we seem to accept is that anything that happens at this higher level, at the level of thoughts, must be at least somehow connected to the level of neurons. That you cannot have thoughts without something happening at the level of neurons. How do we know this? Because our neuroscience seems to tell us that. It's implicit in our contemporary neuroscience that the mind is a product of brain processes. They may or may not formulate it in this way, but this is what any working scientist has in mind, or in brain, should I say. So what is the view implicit in this? This is the view that we call materialism. Another name for this is ontological physicalism, but I like materialism better. Essentially, it says that there is only one substance, and that substance is matter. Which view, implicit in the Newtonian and Cartesian worldviews, did this replace? Dualism. Right. But there are two substances, matter and mind. Now we're going to play a little game here. Matter, mind. According to dualists, there are purely material entities. In organic matter, it could be organic, it could be animals. And there are purely spiritual entities. It could be angels, it could be the creator. And there are citizens of two worlds, material and spiritual creatures, like human beings. What if, for the sake of argument, I move the boundary from here to there? What if I said that animals too have minds? What sort of a view would this be? Still dualism, because you still have two substances. What matters is that you still have entities that are purely material and entities that are purely spiritual, and that's what matters. It's still a version of dualism, because you accept the existence of two substances. Very good. Now I'm going to move this further. What if I said that even plants are, in a sense, spiritual, that they essentially have a capacity of, if not full-fledged thinking, then at least they have emotions, feelings, and some basic level of thinking. What sort of a conception would this be?
Dualism.
Still dualism. Would be a very weird type of dualism, but still dualism. Now I'm going to take this to its extreme. I'm going to say that even inorganic matter is, in a sense, spiritual. What sort of a view would this be? Essentially, in this case, you no longer have things that are purely material. Everything has a mind, but not everything has a body. And this is the view that is known as idealism. There is only one substance, and that substance is mind. So mind can exist on its own, but in order to have something material, you need to have a mind that lays in the foundation. Rob, you had a question?
I find the view a little confusing because you're still saying there's matter in mountains, trees, and animals and humans. So by matter, do you mean something different in this case if it's idealism?
Not really. Now, idealists do not deny the existence of matter, do not necessarily deny. What they do deny is that matter can exist on its own, can exist as an independent substance. What they're saying is that all that exists is essentially spiritual. So this is all fundamentally mind. There are different versions of this. One version is normally known as subjective idealism. This is the idea that everything that you see only exists in your mind. It's only your feelings, emotions, it's only your sensations. Okay, so this is one version of it. But you shouldn't really go that far in order to be an idealist. You can say everything that exists, material things, yes, they do exist. But at the foundation, they are spiritual. They require some universal intellect to hold these things. So they only exist insofar as their existence is maintained by something spiritual. Let's go back to dualism here. What if I said that I believe that there are angels, but that they also have material bodies? What sort of a viewpoint would this be? Dualism, because there's still two substances, because you still believe that you can have something purely spiritual and something purely material. Now I'm going to push this all the way to the right. What if I said that I do believe that there are gods, or there is God, but he is also material. He's not pure mind. He's not pure soul. That he's more like that. What sort of a viewpoint would this be? This is what we call materialism. Now, materialism comes in different flavors, and this is not the version of materialism that you normally have in mind when you talk about these things. The version of materialism that you normally have in mind is something like this, that you have the material world, everything is material, and then at a certain stage of development of this material world, you arrive at certain species that have brains such that are capable of producing thoughts, rational reasoning, theories. But they only exist insofar as there is an underlying brain that does the thinking. So this is the normal version of materialism, the usual version. But it may come in different varieties. What if I told you that human beings are not the only creatures that are capable of thinking? What about this? Let's say 200 years from now, when we finally conquered the problem of artificial intelligence and we taught our machines to think, not just to calculate, but to think. Can anyone tell me why this still would be materialism?
Because there's no substance there that consists solely of a mind.
And how would you interpret the thought processes here?
You need the matter existing in order for the thought process to be implemented into the entity.
Essentially, yes. It can be your Asimovian positronic brain, or it can be some network of neurons. It doesn't really matter. As long as there is something material that does the thinking, that's materialism. And we can also think that there are aliens who are capable of thinking. Still would be materialism, because you have the material substratum that does the thinking. Okay, what about this one? How about I said that everything in the universe is both material and spiritual in a sense? That God is universe and universe is God, and there is nothing in the universe that is not divine, and there is nothing divine that is not in the universe, that they cannot exist without each other. They are two sides of the same coin. There has been such a belief, and it's quite popular, especially among professional philosophers. This is the view, and it is called neutral monism. It's the idea that there is one substance, and that substance is both material and spiritual, that they cannot exist without each other, that they are two parts of the same thing. So here are the two questions that separate these four views. Question number one, is mind a substance? Can mind exist without any material foundation? Can you have souls without bodies? Can you have thoughts without brains? This is the question. You can answer yes or you can answer no. And there's the second question. Is matter a substance? Can you have something material that is not ideal in any way, that does not require any thoughts, any feelings, any spiritual foundation? Again, you can have yes and no. Now you tell me, if I say yes, if I answer yes to both questions, what view would this be? Dualism, exactly. If I say, yes, I believe that matter is a substance, but for thoughts, for mind, you need something material, what view would this be? Materialism. This one, if I say yes to mind, but no to matter, idealism. And finally, this one would be neutral monism. Is this clear? Let's play a game here. How many dualists do we have here? Okay, not too many. How many idealists? How many people who believe that everything is spiritual, essentially? How many? Oh, not very popular. Okay, how many neutral monists we have here? That it's all two sides of the same equation. All right, quite a few. And the materialists? Confess. This proves my point. We live in the age of materialism. Right, I'm going to give you another diagram here. This time, same conceptions arranged by the number of substances that they accept. How many substances are there? You can say one, that would be monism. There is only one substance. You can say two, that would be dualism. And then you can say many. And this would be pluralism. It was implicit in the Aristotelian worldview. We covered this. They believe that every type of thing is essentially a different substance. Now, what about monism? It comes in three varieties, and you know the varieties. Materialism, idealism, and neutral monism. So they are all types of monism. Once again, it is this materialistic variety of monism that is implicit in our theories. There is an open question here, which is, can you really explain everything that happens at the social level or at the level of human culture, human thoughts? Can you really explain that, everything, just by analyzing the motion and the interaction of the neurons? This question is open. Some people say, as long as you know how neurons interact, you must be able to explain everything that there is to explain at the level of thoughts, at the level of the mind. Other people tend to believe that there is something at the level of human thoughts that is not really explicable in terms of chemistry, physics, biology. And this is an open debate. The communities seem to be divided here. But when it comes to the question of the substance, whether there are non-physical substances, the community seems to be in agreement here, that we do not believe that there can be non-physical substances, non-material substances, right? We do not believe that mind can exist on its own. As a scientific community, we don't believe in that. Very good then. Now, next important transition concerns the very concept of matter. If you compare the notion of matter implicit in the Cartesian mosaic, it was purely mechanistic, inert matter. A typical instance would be a billiard ball. No other qualities, just the capacity to occupy space. And then they switched to the Newtonian view, the dynamic matter, a matter that is capable of interacting through forces. Another important transition happened in the 19th century, and yet another one in the 20th century. I'm going to explain this. Here we have the classical experiment. You have a solid wall here. You have a wall with two slits. And here you have a golfer that hits blue-tinted golf balls. So it's a macro-level experiment, all right? What pattern will emerge after a series of hits here at this ball? Two blue lines, right? Should be like that. This would be the view from the top. So far, so good. What about this setting now? Now I'm going to close one of the slits. Only one of them is open. And then I'm going to have a source of light here, like that. What kind of a pattern do you think will emerge? A line. It's a safe assumption that you have to be able to see a line. So now I'm going to open the slit. I'm going to open it. So what do you think we have to be able to observe? Two lines? How many of you think it's two lines? Okay, now you know where I'm going. This is what you would expect if the light had corpuscular properties. This is the anticipated pattern. All agree? No. What do you mean no? Who said no? Okay, tell us why. You might be onto something because we're going to get there eventually.
Anthony, I didn't mean to actually hold the mic, but
I'll make sure that this goes into production, don't worry about it.
I'll be famous. If the slit is narrow enough, you will get diffraction patterns.
Do you want this or do you want to cut? All right. Send me an email, I'll send you my bank account. Right, so in reality, you observe something like this. And this is where it gets crazy. How on earth you see something like this? This has no explanation if you think of light as a series of particles. If you think that light is a series of particles, then you have to be able to see two lines, just like in the case of a golfer and a tinted golf balls, right? Because it's all particles. What this example shows us, that light is not really corpuscular. So what's going on here? The explanation was provided by the wave theory of light. This is the theory, we've discussed this. You remember that bright dot in the center of the shadow? The same theory explained this phenomenon. It says this pattern is caused by the interference of light waves, because light is a wave. So what happens is that you have a wave, it passes through two slits, and then as any wave, think like water waves. What would happen if you had a water wave? It would pass through the slits, and then it would bend around the obstacle, and then the two waves would meet again and interfere. The same thing happens here. There are two types of interference. One type is called destructive interference. This is when the crests and troughs, you see, the crests and troughs of the two waves are out of phase. When it happens this way, they cancel each other out, and those parts of the screen are dark. And there is also constructive interference. This is when the crests and troughs are in phase, and this is when the two waves reinforce each other, and then you get bright lines. So this phenomenon was explained by the wave theory of light that was accepted for about 60 years in the 19th century. And after that, this theory became incorporated into what we nowadays call classical electrodynamics. Maxwell, Faraday. The same type of explanation was given in the classical electrodynamics. Light was considered a wave. This is the view. There are two types of matter, particles and waves. This was a transition from the Newtonian view that matter is just particles that interact through forces. In this view, you have two different types of matter. Some things are particles, other things are waves. Light, electricity, magnetism, those were all waves. And then you had the particles. They believe that there are two types of things. Some entities are thought to be corpuscular in nature, like this one. Other entities are thought to be essentially wave-like. And this was the view accepted all the way until the 1920s. And then it was replaced by the view that we nowadays accept. The view that says everything in nature has both corpuscular properties and wave properties. How is this even possible? This is where the real craziness begins. For that, we have to go to this one, quantum mechanics. If there is one piece of a contemporary mosaic that nobody really understands, it's that one. It's really, really crazy. And here is why it is crazy. The same situation, but this time we go into the micro world. So it's all very, 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 very tiny. Even tinier than that. Okay? It's very tiny. You have the same setting, and here you have a particle gun. It fires individual electrons, one electron at a time. Not two electrons, just one electron at a time. I'm not sure I'm making the right sound, but you get the point. What pattern will emerge on the wall? You say, well, it depends on whether electrons are particles or whether they are waves, right? If they are particles, we'd have to see something like this. So this is the pattern if electrons were particles. In reality, we see something like this. And then you say, oh, that's easy then. Electrons are waves. That's a natural step to take. If this is a pattern, we know this is exactly how waves behave. Therefore, electrons are waves. And again, we don't have many electrons. It's one electron at a time and still get the same picture. Therefore, we conclude that every individual electron is wave-like, and it passes through both slits at the same time. If it's a wave, if it's not a particle, if it's wave-like, if it's fuzzy, you know. Imagine a drunk electron passing through. So it passes through both slits. And then it interferes and the lines appear. Okay, let's confirm this. I'm going to confirm this by putting a small detector here. If the electron is really a wave, it should pass through both slits at the same time. And therefore, the detector would say both slits. The detector is needed to know through which of the two slits the electron has passed. If it's the right one, the detector would say right one. If it's the left one, the detector would say the left one. And if it's both, just as we expect, it would say both. And that would be very nice. And this is where spooky things start happening. This is what happens. The moment you put a detector there, two things happen. First, it always passes through one of the slits. The detector always says right or left or left or right, but it never says both. It's always one or the other. And then the next thing that happens, interference patterns disappear. Always. So essentially it starts to behave like a particle. What on earth is going on? Then you remove the detector and it's back to its normal ways again. You put it back and there you go. No interference patterns. So what do? This is not just one clumsily done experiment. These are the experiments that are in the foundation of quantum physics. So what do you do? How would you react? The view that is accepted nowadays is that all matter has both wave and corpuscular properties. In some cases, corpuscular properties manifest themselves. In other cases, wave properties manifest themselves. But we seem to believe that every particle has wave qualities. In some situations, electrons behave like corpuscles. In other situations, electrons behave like waves. And essentially, all the particles of our standard model, quarks, leptons, bosons, all of them exhibit this dual behavior. All of them have that. And this is the reason why we believe that in reality, we deal not with particles, but with what can be properly called wavicles. They are wavicles. This behavior, this dual behavior, is expressed in many equations of quantum physics. One of them is Heisenberg's uncertainty principle. What is that principle? Essentially, what we seem to believe these days is that since we deal with something wave-like or cloud-like, if you want, when you try to measure the position, what happens? You disturb the momentum. And then when you measure the momentum, it becomes all fuzzy and then it's no longer localized. So you don't really know the position. So depending on which one of the two properties you want to measure, you get an uncertainty in the other one. So the more precise you want to locate it in space, the less precise is the momentum. The more precise you want to make the momentum, the less precise is the position. We have a whole bunch of theories that try to make sense of this difficult situation. Some suggest that these particles or wavicles that we observe are only the results of vibrations of tiny supersymmetric superstrings. Familiar with superstring theory, we talk about that. If we ever accept the superstring theory, that would provide a nice explanation for this, although the concept that is going to be used for explaining this is even more crazy because superstrings exist in an 11-dimensional space-time. This is really crazy, but the explanation, the currently accepted explanation, is that it's because of the dual nature of these particles. It's because it's not really localized. It's not like a billiard ball. There's an old joke that says, why is it that quantum physicists are so poor at sex? Because when they find the position, they can't find the momentum. And they find the momentum, they can't find the position. So I apologize again. Right, let's sum it up then. Cartesian, Newtonian, contemporary. So we had dualism, and it was replaced by materialism, right. We had mechanicist conception of matter that was replaced by the dynamic conception of matter, matter with forces, and then within the Newtonian worldview was replaced by the idea that it's particles and waves. And then this was replaced by wave-particle duality. Now I'm going to give you one conception shared by both Cartesians and Newtonians and rejected nowadays. Dualistic determinism. What is this? This problem, the problem of determinism, is actually the one that convinced me to do philosophy. Essentially, the question is, you have a system, let's say this, and then you manage to know somehow all of the initial conditions, the absolutely correct description of the current state. Forget about our fallibilism for a second. Forget about the impossibility of that. Suppose for the sake of argument that you know everything that there is to know about the initial state of the system. In this particular case, it would be the mass and the position and whatever the shape, whatever things are important in this case. The question is it always possible to predict the future states of this system? Suppose when I let this go. In other words, does nature know where it goes at all times? Is the future strictly determined by the past? Or is it possible for the future to be not determined? Can there be things that are not really caused by anything? You see the question? We're going to start with the Newtonian physics and the 4 laws. We've covered the laws. I'm going to zoom out. It follows from the laws that in any material process, pay attention to the word material here, the same initial conditions always produce the same effects. In this particular case, you have a cannon. If the initial conditions are absolutely the same, then what happens is that you're going to get exactly the same effect. Again, you know it's going to be the same, right? Why do you know this? Because the initial conditions are the same. It's been pre-programmed that way. The same initial conditions produce absolutely the same effects. This is what follows from your Newtonian laws. This is true for any material process. If you take, let's say, a very simple system, a falling apple, when you know the initial conditions of the system, in this particular case it will be masses and forces, you can in principle calculate and predict every future state of the system if you know the initial state. And even if you don't know, you can be absolutely sure that nature itself knows where it goes. You, as a student of nature, may or may not be in a position to do all the calculations because it might be so many different parameters. You may or may not have the knowledge required for that. But if you accept the Newtonian laws as the true descriptions of the world, then you also have to accept in any material system, the future state is determined, strictly determined by its current state. Let's take another example, the Earth and the Sun in this case. Again, when we know the initial state of the system, we can in principle calculate and predict every future state of the system. Sometimes we deal with systems so complex that it's technically impossible to measure the current state. Technologically impossible. But if we were able to measure the initial conditions, we would be in a position to predict with absolute precision what would happen within a day or two or a month or a year if we knew the initial state. The point here is not whether we as human beings are capable of predicting. We know that we aren't. That is not the question. The question here is whether nature itself knows its course, whether there is one future for every initial state, or whether nature itself is fuzzy and doesn't really know where it goes. This is the question. Now, what is dualistic determinism? Dualistic determinism is the view that all material processes are strictly deterministic. Their future states strictly follow from their past states. It applies to inorganic matter, organic matter, everything material. But this doesn't apply to the human mind. It doesn't apply to anything that has to do with thinking creatures. The laws of physics do not apply. Why is it that they don't apply for Newton and for Descartes?
Hi, Willie Wilson. Because matter and mind were separate.
Very good. In this worldview, the mind is not material. It doesn't have any material substratum. And therefore, the laws of physical nature do not apply to things ideal, to things spiritual. The mind has free will and can produce uncaused effects. For instance, it can freely create new theories, like that one, or like this one. The mind can make random decisions, albeit very stupid. Should I have a slice of pizza or a cheeseburger? Either way, it's going to kill you. Don't do it. And then you decide to have that one. But the thing is, your choice is not limited to the two. You can choose something more healthy or even more healthy, like that. The point is, the options, according to this view, are infinite. As a free creature, you can choose whatever you want. So the laws of strict causation do not really apply to you. This is the view that we call dualistic determinism. While in the material world, all events are strictly deterministic, a mind is free to act spontaneously, make random decisions, thus free will. So this view was implicit in both Cartesian and Newtonian mosaics. What other options we have? I'm going to give you the options first, and then I'm going to tell you the contemporary view on the subject. There is the classical view, which is called determinism. This is the idea that everything is strictly determined, including the human mind and any other possible mind. You understand the consequences of this view. So everything is determined. Not only the physical processes, but also mental processes, the processes in the mind. So this is the view. We call this one strict determinism. This is what he says. Suppose it appears to you that you have two choices, and then you think about it, and you freely make a choice to eat this cheeseburger here. Even in this case, a strict determinist would say, well, there's a cause. You may or may not know what that cause was, but there was a cause. There was something that caused you to choose that cheeseburger. You may have no idea what caused that. But there must be some process within your mind or within your brain, depending on whether you're a materialist or idealist, it doesn't matter. There must be something that caused you to do that. And there is something, regardless of whether you know about it or you don't know about it. So there is essentially no such thing as free choice. It may appear free to you, but in reality, in this view, it's all pre-programmed, essentially. And this includes, to the last millisecond, the moment of your birth, everything that's going to happen to you, the moment of your death, doesn't matter. For strict determinists, for any set of initial conditions, there is one and only one outcome. Nature knows where it goes. Okay, another opposite view is called indeterminism. Indeterminists say that there can be uncaused events, spontaneous events, and these events may exist in the mind and in the physical world. So it's not only here, but also in the physical world. That is indeterminism. Essentially what they're saying is that, at least in some cases, for some initial conditions, there can be an infinite number of possible outcomes. So it can turn out like that, or it can turn into a nice seahorse, or it can turn into a falling apple, or if it's really your day, it can turn into a nice cup of coffee. You say, well, this is nonsense, but if you accept the position of indeterminism, the idea is that at least in some positions, miracles are possible. This is proper indeterminism. This is how it's defined. Uncaused events, events that have no cause whatsoever, completely spontaneous. In literature, if you read specifically popular literature on quantum physics and philosophical issues surrounding quantum physics, very often our contemporary view that we nowadays accept is called indeterminism. But that is absolutely incorrect. It doesn't make much sense to debate the labels, but I suggest we stick to the classical notion of indeterminism. And as long as we understand indeterminism in this way, we are not indeterminists, because we do not believe that anything is possible. We do not believe in that. That is not the accepted view. The view that we accept is different. And in order to understand that view, we have to go back to quantum physics again. Quantum physics. We have here an atom of radium. 88 is the atomic number, which is the number of protons, these red ones in the nucleus. And here, 2 to 6 is the number of nucleons, which are protons and neutrons put together. Okay? And this number decides which particular variety of radium we are dealing with, or which isotope of radium we're dealing with. In this case, this would be radium-226. Now, we know that radium is radioactive because it eventually decays. It decays into a radionucleus, you see 222 and 86, and a helium nucleus, or we call it an alpha particle. 2 protons, 2 neutrons, 4 nucleons. According to our theory, and this is what quantum physics tells us about this, it says the half-life of radium-226 is about 16 centuries. In other words, there is a 50% probability that an atom of radium-226 will decay in 16 centuries. Let's say you have 100 atoms of radium, put it in a box, seal the box, come back in 16 centuries, may God grant you the longevity, come back in 16 centuries, you open the box, you're going to see that roughly 50% of them decayed. Now, quantum physics tells us that there is a certain probability for a decay to happen. The important thing is that the theory doesn't tell you which particular atom is going to decay at a certain point. The theory doesn't tell you that. The theory says that there's a certain tendency for the decay to happen, but it doesn't tell you when exactly the decay is going to happen. It tells you that statistically speaking, roughly 50% of them will decay in 16th centuries. But it doesn't really tell you exactly when a given atom will decay. What does this mean? This essentially means that all events have certain causes, but the same initial conditions may produce different effects. In literature, again, this is the view that we call indeterminism for whatever reason, but this is not indeterminism. I'm going to use, for lack of a better term, this one, probabilistic determinism. This is what he says. For any set of initial conditions, there is a limited number of possibilities. It can be like this, it can be, you see a slight mutation here, or the number of offspring can be different, but it can never turn into a cup of coffee, even if it's your lucky day. Nature here chooses from a limited number of possibilities. The number of possible outcomes is limited. And this is the difference from proper indeterminism. If you're indeterminist, you don't have to say that nothing has a cause, right? That's not what you're saying. You still can believe that this thing, when you let this go, it has a cause. If you're an indeterminist, for you, all events can be roughly divided into 2 types. Those events that do have causes, and those very rare events which have no cause whatsoever. For an indeterminist, there are cases when anything can happen. And strictly speaking, it's the same as to say that there are cases when there are no causes. We believe that it has a cause. The cause is its structure, its atomic structure, the very nature of radium. That is the cause. It's just the cause doesn't determine the outcome with strict precision. It only determines the probability. The important point here is that it's not a lack of knowledge on our part. If you accept probabilistic determinism, you must believe that nature itself has an open course. Not very open, open to a certain degree. There are limited options, and at any moment of time, nature chooses from a limited number of options. So it's not us, human beings, that are incapable of getting to the essence of things, but it is nature itself that is not really sure about its course. So in this particular case, in 16th centuries, it can continue like this, or it can end up like that. But again, no seahorses are expected in this case. The options are limited. Well, in this particular case, it is impossible to say with certainty where a given electron will strike the screen after passing through the slits. But there is a high probability that it will strike in one of the bright bands. So if we look at this diagram, the top view, and this is your probability, this curve would represent the probability of finding an electron in different areas on the screen. So this is what the theory tells you. It tells you that this is the probability for finding it here, that's the probability for finding it there. But it doesn't tell you where exactly it's going to happen. Now, those of you who know a thing or two about these things, you probably heard of a famous debate between Einstein and Bohr on the subject. Albert Einstein said, in this situation, it's a limitation of human knowledge. It's you, as scientists, you don't know what's happening. But nature itself obviously knows the outcome. The improved technology, improved science, we may hope that one day we will conquer this issue and we'll know exactly when every single electron should strike the screen, when every single atom of radium should decay. So we will have precise, strictly deterministic predictions for these things. The accepted view, essentially, is the one that is not Einstein's. The view that we nowadays accept is that, no, there are actual probabilities out there. My question is, do you think that what Einstein says makes sense? How many of you think that Einstein's position actually makes sense? That it's only a limitation of human knowledge, that we will dig deeper and we will know the actual reasons and we will be able to calculate with absolute precision? How many of you support Einstein? Now, at a personal level, I may tend to agree with you, but there is a certain risk. When we take the step as scientists, I'm talking now not about my individual view, I'm talking about the scientific community and me as a member of that community. Individually, I may believe in anything, but as a scientist, I have two options. Either I say, this is what my current theories tell me, and this is what I have to accept. That's option number one. Option number two, which you always have, you can say, you know what, our theories are imperfect, and I'm going to stick to the belief that I have, regardless of what my contemporary theories tell me, because my contemporary theories are not the final ones. We are all fallibilists when we know they're not the final ones, right? This is option number two, to stick to whatever belief is close to your heart, regardless of what your theories tell you. But you see, Einstein's strategy can be applied at any time, no matter what your scientific theories tell you. You can always say, oh, you know the theories are fallible, there is still a chance for God to exist. Yes, there is. At the individual level, you can believe whatever you want. But the scientific community doesn't have a choice. We have to stick to the theories that we have. Keeping in mind that these theories are fallible, but if we're talking about the scientific worldview, I think the proper option is to look precisely what our scientific theories have to tell us and accept the results. It doesn't mean, again, that individually you cannot say, well, there must be a different theory, I'm going to elaborate and work on that theory. I, for one, believe that there is more to the story than this picture allows. But I still appreciate the fact that according to the current theories, the world is not strictly deterministic. Let's stick to the theories that we have. This is what separates the scientific worldview from an individual worldview or any other worldview that is not based on scientific theories. It's safe to say that nowadays this view is implicit not only in our fundamental physics. Take any field of science, you'll find probability implicit in it. Do we have people majoring in social science? Have you come across any probabilities in social sciences? Economic predictions, demographic predictions? It's not only social science, biology. So it's safe to say that this view is implicit in our theories. There are some exceptions, but it's sufficient to have at least some theories that say that at least in some situations, nature offers options. I don't want you to think that the debate is over. I don't want you to think that, okay, it's probabilistic determinism once and for all. No, it's not. Einstein may turn out to be right. We don't know. But what we do know is that given the current state of affairs in science, this is the prevailing view. It's a safe conclusion to make. It gives you a chance to work and elaborate different options. But again, the important thing here is that we have to be in a position to keep the score. You can work on whatever you want. You can pursue whatever idea you want. But you have to keep the score. Let's sum it up. So this was the initial question. Can there be uncaused events? Yes or no? Indeterminism, determinism. I'm going to move this. But then we also have dualistic determinism. And since you have the third view, my dear philosophers, you know that when there is a third view, there must exist another question to which this one says yes, and these two say no. How would you formulate the question that separates dualistic determinism from these two? How would you formulate it? In such a way that these two say no, and dualistic determinists say yes. This is the way I would put it. Can causation and spontaneity exist in different worlds? Is the question of having the two, but in different worlds. In one world, you have strict causation. In another world, you have free will, spontaneity. So this is the idea that both of these views would say no. Strict determinist or indeterminist, you would say there is no such thing. There is one world, either it's all strictly determined, or there are uncaused events everywhere. You can only stick to dualistic determinism if you believe in two substances, if you believe that the world is strictly cut into the material part and the spiritual part. But you cannot really have this if you believe in one substance. We're going to zoom out. Now we have a different view, probabilistic determinism. And this view brings another important idea, that all of the previous ones would say, no, it cannot be. What is the idea that probabilistic determinists introduce? How would you formulate a question that separates probabilistic determinism from the three other views? So there must be something in probabilistic determinism that all the previous views would consider unacceptable. It's the idea of non-linear causation. It's the idea of an open causation. It's the idea of the causation such that the same initial conditions produce different effects, limited number of different effects. And this is an idea foreign to strict determinists, indeterminists, dualistic determinists. If you asked Einstein, he would say, no, this idea is nonsense. It's a contradiction in terms. If something has a cause, then it has to follow from that cause in a straight line. If something doesn't have a cause, then it doesn't have a cause. The idea that something may have a cause and yet follow from that cause in an open fashion, in a non-linear fashion, is a contradiction in terms for any of these views. You see? So you can only accept probabilistic determinism if you believe that the same initial conditions can bring about different effects. Very good. Tell me, which element of the Cartesian, Newtonian, and Aristotelian worldviews is no longer part of our mosaic?
It's theology.
It's theology. It's part of the scientific mosaic all the way until the early 20th century. In different communities it was different. In some communities, theology was separated from science in the 19th century, early 19th century. Some communities went all the way to 1920s, 1930s. But roughly it's the beginning of the 20th century. Theism is the conception that God exists. The accepted view was a specific version of theism, is the idea that there is one God, monotheism. It was this view that was implicit in the Cartesian worldview, in the Newtonian worldview, in the Aristotelian worldview. Nowadays, the scientific community accepts the position of agnosticism, and it should not be confused with the position of atheism. The only reason why I bring this up, this is not a huge topic to discuss, there's not much that we can discuss based on scientific reasoning here. But one thing I want you to keep in mind is a distinction between agnosticism and atheism. There is no scientific theory nowadays that says that God does not exist. We don't have evidence for that. The view that is implicit in the scientific mosaic is the one that we just don't have evidence. It's not a scientific issue. We just don't know. May or may not, but it's not a scientific question. You see the difference here? We do not believe that God exists, but we equally do not believe that it doesn't exist. We just refrain from answering the question. We just don't think it's a question that we can tackle as scientists. So again, on a personal level, you might be a believer. I might believe in God, but it doesn't make the scientific community a theological community. So theology is no longer part of our mosaic. And it was replaced, the idea of monotheism was replaced not by the conception of atheism, but it was replaced by the conception of agnosticism. The tough part here is that this question, why was theology exiled, doesn't seem to have a simple answer. We have all sorts of stories as to how it was exiled. It was a gradual process. It wasn't exiled in a day. The final one that was exiled was the proposition that there is a creator of the universe. That was exiled, but it was the last to go. Before that, there were many others that gradually were exiled. So it was a gradual process, but essentially, we don't really understand the mechanism of it, and we do need to understand the mechanism. By the theory rejection theorem, you know the theory rejection theorem, it says that a theory becomes rejected from the mosaic if and only if it is replaced by some other theory. So what was that element or a set of elements that entered into the mosaic which forced the theology out of it? So this question is not a simple matter. It could be biology, it could be something in physics, it could be, I don't know, I don't want to hypothesize, it's an open question. All right, let's sum it up then. Dualistic determinism, we have probabilistic. Monotheism, we have agnosticism. I didn't touch upon the hypothetical deductive method because we've covered this on many occasions and we share the same method with the Cartesians and Newtonians. A few more things. Action by contact, action at a distance. And then we had plenism, vacuism here. We had infinite universe, infinite universe. What are the contemporary views on these issues? Why didn't I cover this? There is one reason why I didn't do that. I want you to tackle these issues on your own or by taking other courses. I'm just going to give you some hints here. Should quantum entanglement and non-locality, these are the terms to Google if you're interested in these things, quantum entanglement and non-locality be interpreted as instances of action at a distance? In general relativity, is space an attribute of matter or is it a separate substance? Is it plenism, is it vacuism, or is it something else? It's an interesting question. Infinite and boundless. Boundless and infinite. Are they the same thing? Or can you possibly think of a universe that doesn't have any boundaries, but is finite in volume? Can you have a universe that is finite, but no physical boundaries? You know, curved space-time allows for those scenarios. It's an interesting thing to tackle. Very good. Next time, what is it that characterizes a worldview? Okay? Thank you very much. Have fun.